Right, for this lesson, we are looking at the difference between relations and functions. So things can relate, and but still not be a function. But all functions are some type of relation, so they kind of coexist that way. So a relation is a set of inputs and outputs, often written as an ordered pair, and we think of these as like x and y. That's mostly what we deal with, but you can have other variables. And a function is a relation, so it is a inputs and outputs, but there's only one and exactly one output for each input. So if I put in a 3 and get out a 5, every time I put in a 3, I should only get out a 5. I shouldn't change at all. So when you plug this in, you get this out. When you plug one thing in, you get one thing out. The graph of a function is just the set of all the ordered pairs, every single one. So when we are graphing it, we have smooth lines because it's every point, like it's 1.1, 1.111, 1.1111, and so forth. So that's why it's a smooth line, because we usually have an infinitely many points. So each point is tiny, that's making each point on the line. So you can see here we have some functions. Function A, they inputted a white cube and came out a gray cube. And then function, you can see that happened again. They entered a triangular prism and came out a white triangular prism, and it came out a gray. So this function does an input of white, and the output is gray. So you can kind of think of it as a machine. It's doing something. What's it doing? What it's doing is your function. This next one, you can see we went to a cube and out came a square. We inputted a triangular prism and out came a triangle. So the difference from what I inputted to the output is it went from 3D. So my input is a 3D shape. My output is 2D. And try to think of what this next one, see if you can think of or figure out what it is. So I'm going to be looking to see that you try to think of what is this function doing. I'm going from bonk, I don't know, to knob, and then from pin to nip. So they're doing the same function, but what's it doing? So a lot of times in math, obviously we do the same thing, but with numbers. So each machine, you're putting an input and then comes an output, and it's a unique pair. So those pairs are always together. That's what makes it a function, is that the input gives you the exact same output every time I put that input in. So we have another function here. Now we're just naming it f instead of ABC. So notice you put in a 10 and out came a 29. So this function has an input of 10, does some calculation with it, and out came a 29. Same function, put in a 1 and out came a 3. Put in a 6 and out came a 17. 51, an input and an output of 152. Input of 2, output of 5, and an input of 0 and output of -1. So what you can kind of see, and maybe it takes sometimes it's easy to see and sometimes it's not as easy to see, but if we take the input times 3, we get a -1. And I can see that works here, right? So if I take 10 times 3 is 30, minus 1 is 29, so that works. 1 times 3 is 3, minus 1 is 2. 6 times 3 is 18, minus 1 is 17, so still working. So we can see that that's working on each one. So that's what that function is. The function is for your output, that equals 3 times the input minus 1. And those aren't always super easy to see right off the bat. Another thing that we will see is that, so your inputs are your x values, and your outputs are your y's. So on a graph, you have a set of a bunch of, I inputted a 1, I got a -1, I got out a -1. I put a 0, I got a 0. Put in a 1, I got a 1. So those are outputs. So to check to see if it's function, we do what's called the vertical line test. And if it crosses, when I draw a vertical line, if it crosses the function in more than one spot, anywhere I draw a vertical line, then it's not a function, because your outputs are the times it crosses the vertical line, because vertical lines are your in parallel with your y-axis. So this is a function because when I draw my vertical line, it only crosses once. This is not a function because when I draw a vertical line, it crosses twice. So this is not a function because I get 2 outputs for 1 input. Here we can think of our inputs are Fahrenheit, and we're switching over to Celsius. So it's just another way we represent functions is by an equation. So I can put, anytime I put a Fahrenheit degree, I'm going to get an output of in Celsius, the temperature in Celsius. So this would be a function because every time I put the input of like 5, we'll say, we would get the same Celsius degrees. So each input has exactly 1 output. So that is a function. Here we have our inputs here. So notice we put 9 in twice, and they came out 2 different things. One time it came out a 3, and one time it came out a -3. So because it came out 2 different inputs, 2 different outputs, the input 9 gave us 2 different, that is not a function. All right, and here we're going to look for whether things are crossing. So 5 and under pay $3. 6 through 12 pay 6. 13 through 64 pay 12. So all our inputs are these age ranges, and they don't cross at all. So this is still a function. But if you look over at this one, 2 and under is free, but then here 2 to 18 is $5. So does a 2-year-old go in free, or do they have to pay $5? And same for 18, right? 18 either pays 5 or they pay 10. So that is not a function. All right, so our inputs are called our independent variables because that's not dependent on anything. We can plug anything in. The output is called your dependent variables because it depends on what the function is doing. So if that function is taking it times 3 minus 1, then the value I get out depends on what that function is. So the domain is the set of all inputs, or x values. The range is the set of all outputs, which are the y values. So remember, x values run left and right, y values run up and down. So if I want the domain here, okay, sorry about that. I was going to start the video over.